Hi, everyone, and welcome back. It's Kira Garfolo with Greenville Tech's MAT-155. Today, we're going to talk about installment loans, which is section 3.5. In our last section, we discussed simple interest. Remember that we had I equals P times R times T, so we took into account how much we borrowed, times what that interest rate was, times how long we borrowed the money. Simple interest makes the assumption that money is kept for the entire period. So remember that if you borrow $1,000 for 3 years, simple interest is going to make the assumption that you're not going to pay back that $1,000 until the very end of 3 years. And in reality, that's not what happens, right? In the reality, most of us borrow money and we make monthly payments or some other term payments back towards paying off that loan. As such, we cannot simply use that simple interest formula. It's going to give us the wrong answer, okay? If we want to calculate our payments, we want to calculate how much interest we're going to end up paying, that original formula that we used last section just doesn't give us the accurate information. If you want to get super accurate information, you have to use a financial calculator. They're available online. You can actually buy a TI financial calculator, things like that. But we have estimate or approximate formulas that we'll use in our class, and that's really all you need to worry about for the purposes of this class. So let's relate what we did last section to what we're doing today. If we see something listed as an add-on interest rate, then it is calculated just like we did simple interest, okay? It is going to be calculated making the assumption that you make no monthly or weekly or any other types of payments. You're just going to hold on to it, and at the end of the term, you'll pay it all back. So you're going to calculate this just like you calculated simple interest. Due to the way that they're calculated like this, add-on rates look a lot more appealing than they really actually are. Your effective rate is usually much higher. An add-on rate is making the assumption that you're owing that amount for the entire period of the loan. So if you borrow $1,000, then you're paying interest on that full $1,000 for the entire life of the loan. But if you're making payments on installment plans, then you don't owe $1,000 for the whole time. You only owe $1,000 at the very start. And then you owe less than that as you make your payment. If any of you have bought a house or a car, you slowly pay off that house or that car. And so you're not owing the full amount that you borrowed after those first few payments, right? So let's look at some examples here. Let's say that you borrow $800 and you repay it over an 18-month period. The interest rate is quoted as an add-on rate of 7%. Make sure that I can get my pen to work. So we have an add-on rate of 7%. Why isn't the pen not working? Oh, technology is beautiful. Hold on 1 second. We have the add-on rate of 7%. Anytime you see add-on rate, think simple interest, okay? You're going to be thinking about that I equals PRT. And remember that you have a formula sheet. You don't have to memorize these formulas. So if you want to calculate the total amount of interest that you'll pay, use that I equals PRT formula that we learned last section. The principal is how much you borrowed. The rate, make sure you put in the decimal form, 7% is 0.07. And the amount of time annually in years, okay? So if it's a 7% annual rate, then 18 months is going to be 1.5 years. So you're going to pay a total of $84 in interest. If you want to calculate your monthly payment for this loan, you need to look at how much you owe total and divide it by how many months you have. Well, you owe the $84 in interest, but you also have to pay back what you borrowed. You owe a total of $884, and you're going to divide that by 18, and we can quickly see that that was going to be $49.11. So you're going to pay $49.11 every month for 18 months to pay that loan back. Now, again, the add-on rate often looks better than it actually is. If we want to get a better idea of what's going on, we can calculate the APR, which is the annual percentage rate, And in our class, we're going to use an approximation formula. Again, you could use more technical calculators. You can find things online, which you won't be able to do for a test, so don't rely on that other than checking answers. But you can use the formula that APR is approximately 2 times N times R, all of that divided by N plus 1. And in this case, N is the number of payments that you make, and R is that simple interest rate. So if they quote it as an add-on rate, that's what you're using as R. Make sure you use the decimal form. Now, again, this is an approximation, so make sure that if you are doing this in the real world, in your job, where you're talking about large sums of money and a little bit of a difference would make a big difference, that's something that you'd want to consider. But for the math purposes of things, this is a pretty close estimate of what we're going to see. And as we'll see through some examples, APRs are a lot higher than add-ons. This is why they're required now to be disclosed to the consumer. You cannot advertise a loan as a business and say, hey, we'll loan you money for 7%, if that's really just your add-on rate. You have to disclose the APR. If you read your credit card statements, you'll see everything in APR, and they're kind of a scary high amount a lot of times. Let's look at an example. Remember in our example that we had a 7% add-on rate, okay? So they were advertising this loan as 7% add-on rate. If we use this formula, 2 times N times R over N plus 1, remember we were making 18 months payment, so N is going to be 18 months, and we were, we had 7% add-on rate, excuse me, still recovering from a cold. So if we calculate this on our calculator, we're going to see that we get 0.133 or about 13.3%. That's a lot higher than what they were advertising as 7%. So you can quickly see why the government requires that APRs are also disclosed, not just that simple interest add-on rate. Okay, take a moment and pause and go ahead and work this one out. Suppose that you borrow $1,000 and you repay it over a 2-year period. The interest rate is an add-on rate of 8%. So we should be thinking, okay, 0.08 is going to be R, okay? 2 years, we're going to have 24 months. And we're going to borrow $1,000. So first we want to know, what is the amount of our monthly payment? Well, our monthly payment is going to have to be how much interest we pay plus our total, and divide that entire amount divided by how many months we have. So first we need to find the total that we owe, total that we're going to end up paying. So that's going to be based on I equals PRT, and we have to add that back to our original. So our interest is going to be $1,000 times that 0.08 rate times 2 years, which is going to give us $160. Okay. So the total borrowed then or the total paid, let's say, the borrowed plus interest, is going to be the $1,000 that we originally borrowed plus our interest, so $1,160. Our monthly payment will be our total divided by 24 months. So 1160 divided by 24, if we plug that into our calculator, we will see that that is going to be about 48.33. So we're going to pay 48.33 per month. If we want to estimate our APR, remember we can use that formula of 2 times N times R over N plus 1. So this is going to be 2. The number of payments that we are going to make is going to be 24. And our add-on rate is 0.08 divided by 24 plus 1. And remember to use the math print in your calculator or use parentheses, whatever you need to do to make sure that your order of operations is squared away here. And if we plug this into our calculator carefully, we're going to get about 0.1536, which is going to give us somewhere around 15.4% for your APR. Okay, that's a whole lot higher than the 8%. If you didn't get this answer on your own, make sure that you pause and go back and find your mistake. Here's another one that you can practice with. Go ahead and pause if you need to, get the answer, and then you can follow along to check yourself. Suppose you buy an appliance which costs $500 on an installment plan. The interest rate is an add-on rate of 12%, and you finance the appliance for 3 years. What will be the amount of your monthly payment? Well, let's calculate how much our interest is first. So our interest is PRT. So it's going to be that 500 times that 12% times 3 years, which is going to give us 180. So that means that the total amount you're going to pay, which is actually the second question here, is going to be what you borrowed plus the interest. So you're going to pay that $500 for the appliance plus the 180 that you paid in interest. So you're going to pay a total of $680 for that appliance. Your monthly payment is going to be that total divided by how many months? So that's 680 that you're going to pay total, and you're going to divide it by 3 years, which is 36 months. And that is going to give us $18.89. So you're going to pay almost $19 every month for 3 years, for 36 months. And that's going to total up to be about $680, which is going to be how much you're going to pay total versus that $500. What is our true annual interest rate? Well, now we can estimate our APR, which remember is 2NR over N plus 1. So we're going to have 2, N is the number of payments, so 36. R is that add-on rate, so 0.12, all over 36 plus 1. And if we plug that into our calculator, we are going to get somewhere around 23.4%. So you're paying a good bit of interest for that appliance. Now, a lot of times you're not just going to finance the entire cost of something, right? You buy a house, you buy a car, maybe you buy that appliance, you can put some money down. This upfront money is called a down payment, okay? It is important to note that you do not include the finance charge in those calculations, okay? If you're talking about how much you are, how much you're paying interest, how much you're going to pay back to the lender, all of that stuff, none of that is including the down payment because that is already paid and done away with. Interest does not depend on the down payment. So for example, if you buy a car for $25,000, but you put $5,000 down, how much are you borrowing? Well, $20,000, because 25,000 minus the 5,000 that you put down leaves you with $20,000 that you're borrowing. All of your interest calculations, all of your monthly payment calculations are going to come back to this 20,000, not the original 25,000. The only time 25,000 comes into play is when you talk about how much you paid for the car with everything. Let's walk through a very comprehensive example. You purchase a car and the car is $18,000. You trade in a car worth $4,000 for your down payment. So effectively you make a $4,000 down payment. You're going to make 48 monthly payments of $350 each. Okay. So that's going to be 4 years of payments. We want to answer the following question. How much did we borrow? How much did we have to pay back to the lender? How much interest did we pay back to the lender? What's our add-on interest rate? What's our true interest rate, APR, approximately? And how much total did you pay for the car? These are a lot of questions, but they all kind of build on each other and they're all related. Let's take them one or two at a time. So first, we purchased that car and we want to know how much we borrowed. Well, it was $18,000 and we had a $4,000 down payment. So we only borrow $14,000. Okay, simple enough. What about the total amount that you're going to pay back to the lender? Okay, So the total amount that you're going to pay back to the lender is how much your total, you have the monthly payment information here, okay? So how much are you going to pay? Don't count that $4,000 here. You only need to count that you are paying that lender 48 payments of $350. That is going to total up to be $16,800, okay? So you're paying back to the lender $16,800. How much interest did you pay to the lender? Well, remember that your interest is just how much you totally paid minus how much the principal was. So if you paid that $16,800 total and you financed that $14,000, or that you borrowed $14,000 from a previous slide, and you know that this is that 48 times 350 from a previous slide, then your interest must be $2,800. So on that car that cost $18,000, you put $4,000 down, so you're only borrowing $14,000. You're going to pay $2,800 in interest. What's the add-on interest rate? Well, to solve this, remember, when you see add-on, you should be thinking I equals P times R times T, okay? We want the add-on interest rate, which is going to be this R that we're looking for here. We know I, okay? We just calculated that. We know P, because we know we borrowed $14,000, and we know T, because we know that we're doing it for 4 years. So this is the amount borrowed. This is the 4-year term. And this is the interest calculated on the last slide. Okay. To use some algebra here, you're solving for R, just like we did in the first unit, and you're going to see that it gives you 0.05. So your add-on interest rate is only 5% here. Now, what does that 5% come out to with APR? Well, now we need to use our APR formula. We know that we have 48 payments. And we know that our add-on rate we just calculated was at 5%. So if we throw that in, we see that our actual APR is much more accurately represented by 9.8%, almost doubles. Now, lastly, you purchase a car that costs $18,000. We know all that information from our previous slides. How much did we pay for the car? Well, how much did we end up paying to the lender? 48 times 350. We already saw that. How much did we actually pay down before we even talked about financing? Well, that $4,000. So we need to consider how much we paid to the lender and how much we paid up front. So our total of our monthly payments plus what we put down initially, and you'll see that that $18,000 car ended up costing you about $20,800. This is why loan companies exist, right? It's convenient for us because we can pay, not very many of us can cough up $20,000 at once, right? But they also have to make money. And so by lending you that money, you are paying for a service. And that's why you'll pay more for the car in the long run. Okay, this is a great place to pause, certainly pause actually, and work this example. It's just like what we did before. I'm going to walk through it in the slides, but please pause because you're going to see one like this on your test. Okay, you purchase a car that costs $15,000 and you put $2,000 down. You're going to make 48 monthly payments of $375 each. Let's walk through this. I'm going to break it apart in different slides. How much money must you borrow? Okay. So remember the borrowed or the finance is going to be the cost of it minus your down payment. So $15,000 is how much you're paying, and you're going to put $2,000 down. So you're only going to be financing $13,000. Okay. The total amount that you pay back to the lender, not including your down payment, just the amount paid to your lender, is that 48 monthly payments of $375. So you have 48 payments times $375. And if we plug that into our calculator, we'll see that we're going to pay to our lender $18,000. Okay. So $18,000 is how much we're going to pay to the lender. Now, how much interest do we pay to the lender? Well, we know that we borrowed however much we paid minus however much we borrowed. And we know we just found that we paid $18,000 to the lender, right? But we only borrowed $13,000. So that means that we must have had $5,000 in interest. Okay. Now, what is our add-on interest rate? Well, for this, remember we have I equals P times R times T. Our interest we just found was $5,000. We also know that our principal, or how much we borrowed, is $13,000. We're looking for R, and we know that we're making 48 monthly payments, so we have 4 years. Okay. With a little bit of algebra, we're going to see that R is going to be that $5,000 divided by 13,000 times 4. And that is going to give us 0.0962 roughly, or 9.62%. Okay, so that is going to be our add-on simple interest rate, 9.62%. If you're having trouble, you don't have to wait till the end to pause and fix your mistakes, because all of these are going to add. If we mess up one, we're going to mess up one further. Now, what is our APR? Remember that our APR is roughly 2 times N times R over N plus 1. So the number of payments that we're making is 48. And we just found that our interest rate is somewhere around 0.0962 over 49, because that's N plus 1. And if we plug that in, we're going to get somewhere around 18.8%. Okay. So APR wise, you're paying 18.8% for that car. That is costly. And lastly, what's the total amount that we paid for the car? Well, remember that our total is amount down plus the amount that we paid to our lender. And we paid $2,000 down, and we found early on that we had actually paid to the lender $18,000 based on our monthly payment. So we are going to pay a total of $20,000 for the car. So the car only costs $15,000, and we're going to pay $20,000 for it in the long run. Okay, so now we can do even more with APR. If we know the APR from the loan terms or from whatever the problem is going to give us, we can calculate our payments with that APR, okay? And this looks like a pretty complex formula, but please note that this is really the only formula piece of it. Also, remember that you have the formula in your test. It will be given to you, okay? So you don't need to worry about it. So notice here that when you're using this formula, the APR, the P is the amount borrowed. The APR is your annual percentage rate given in the problem, right? N is going to be your number of payments per year, and T is going to be the loan term in years, okay? Here are some common things for you. If you're making daily payments, you're going to pay 365 times per year, weekly 52, monthly 12, quarterly 4, and semi-annually 2, okay? Keep these in mind as you read the problem. So let's work through this example. Let's talk through it, okay? If any of this doesn't make sense to you, you should pause, review the text, review what you need to make sure it makes sense, because you will see one of these also. So find the payment amount if $150,000 is borrowed for 15 years at an APR of 5.5%, and you're making monthly payments. So here, you know from monthly payments that you're going to have N is 12. P is going to be your 15 years. $150,000 is going to be P, and your APR is going to be 0.055. Remember to put it as a decimal, okay? If we plug all of that into our formula, we will see very carefully in our calculator. Most problems with this are calculator problems. We're going to get $1,225.63 each month. Okay, so if you borrow $150,000 to buy a house on a 15-year mortgage, let's say, at an APR of 5.5%, then your monthly payment is going to be a little over $1,200 a month. Now you give this one a try. Pause, do what you need to do. We want to find the payment amount if the APR is 18%, so 0.18, and $10,000 is borrowed, so that's P, for 5 years, that's T, and monthly is going to tell us the N is going to be 12. So our payment is going to be $10,000 times 0.18 divided by 12, all over 1 minus 1 plus 0.18 divided by 12 to the negative 12 times 5. Now be very careful. This formula trips a lot of people up, okay? Careful. I would certainly use math print in your calculator. And I would certainly do a practicality check when you're done. Does that make sense? Okay, if you get an answer that you're going to be paying $120,000 a month, you might want to check and make sure that you didn't miss a decimal somewhere or mess up parentheses or something like that. Plugging this into our calculator, we see that we're going to get roughly, if you want to spot check yourself midway through, you're going to get around 150 over 0.5907. Which is going to give us a monthly payment of $253.93. So make sure that you can calculate and get this answer. Let's do one more. Let's say that you're borrowing $50,000, so that's going to be your P, for 3 years, so that's your T, at an APR of 0.08 or 8%. And payments are made semi-annually. Remember, semi-annually means every 6 months. So we're going to have N equals 2 here. So we want to find our payment. So our payment here is going to be that $50,000 principal times 0.08 over 2, all divided by 1 minus 1 plus that 0.08 divided by 2. Raised to the negative 2 times 3 years. If we carefully plug this into our calculator, we're going to see that our payment is $9,538.10, which sounds like a lot, right? But think about it. We're only paying, or we're only borrowing it for 3 years, and we're only paying twice a year. Okay, so you're only going to have 6 total payments, and you're borrowing $50,000. So that sounds about right with an APR of 8%. So yes, this is practical. If you got that for monthly and you were paying monthly for 3 years, you'd absolutely get a red flag and say, oh, wait a second, I probably messed something up. Okay, I understand that this is a very heavy section. It's probably our heaviest section yet for most people. If you have questions, remember that you are going to be able to look in your text. You can email me, you can check the Math Center. Definitely get lots and lots and lots of practice. There are so many problems in your text. There are problems on the practice tests, okay? There are problems on my old test if you want to see exactly the type of problem that you're going to be asked to do. Do not blow this one off, okay? I don't want to see you miss big time questions on the test. Remember, if you need help, I'm always here. And there's only one more section left for this unit, so I'll see you guys soon.